Hello, today I'm going to be showing you Geoboard. Now mine is a 7x7 double-sided. This grid pattern here can be used to teach children shapes. It can be used to teach, area and perimeter. Sometimes they come with neat little inserts that already have pictures so that the children can copy the shapes on there with bands. Now, mine didn't come with any bands, and normally they do. So for the activities, I'm going to be using my daughter's hair bands. So you don't necessarily need Geobands to make these activities work. On this side, I have a round grid. This can be used for pie charts and determining angles, and even a clock to teach children how to tell time. Let's get started. Let's start with basic shapes. We can create squares. By simply stretching our Geobands, across the pegs. When you're using a Geoboard, you don't want to count the pegs when calculating the side length or the area or the perimeter. Instead, you want to count the spaces. So we can also create rectangles in the same manner. Different size Geobands to create different size shapes. We can also create triangles using Geoboards and Geobands. We can also create kites. This is a fun way to keep kids occupied and also teach them their shapes without them knowing. We can create a trapezoid. We can turn this trapezoid into a hexagon or to an octagon. The possibilities are endless. We can use Geoboards to find things such as area and perimeter. So let's go back to that 2x2 square. And that 1x3 rectangle. Let's recall the area formula. Area equals width times height. Starting with the square, let's determine the width and the height. So counting the width, we'll count spaces across. We have 1, 2. And for the height, we'll count the spaces down. 1, 2. Now let's plug these numbers into our formula. Area equals width 2 times height 2. Area equals 4. We can also just use the Geoboard to determine a shape's area by counting the spaces. 1, 2, 3, 4. Let's try another example with our rectangle. So we know our area formula is area equals width times height. Let's go back to the geoboard and our rectangle to determine these measurements. Width will count the spaces across, 1, and height will count the spaces down, 1, 2, 3. So plug in the numbers. A, area, equals width, 1, height, times 3. Area equals 3. Again, we can just count our spaces. 1, 2, 3. Using this same 2 by 2 square and 1 by 3 rectangle, we can also calculate perimeter using the geoboards. Now let's recall our perimeter formula is P equals 2W plus 2H. W being width and H being height. Using our geoboard, we know how to get our width and our height. We simply count the spaces. So our width is 1, 2, and our height is 1, 2. Let's plug those numbers in. W equals 2, H equals 2. We can plug these numbers into our formula so that P equals 2 times 2 plus 2 times 2. Now, order of operations, we know that we have to multiply first. So we have 2 times 2 is 4, plus 2 times 2 is 4. That gives us a perimeter of 4 plus 4 equals 8. We can also simply count our spaces on our geoboard. 1, 2, 3, 4, 5, 6, 7, 8. The perimeter of a 2 by 2 square is 8. Let's move on to our rectangle. To determine the perimeter of our rectangle, we have to recall our formula for perimeter, which is P equals 2W plus 2H. Let's use our geoboard to get our measurements. So W will be the spaces across, 1, and H, height, will be the spaces down, 1, 2, 3. We can plug these numbers into our formula. P equals 2 times 1 plus 2 times 3. Order of operations, we know that multiplication must come first. So 1 times 2 is 2, and 2 times 3 is 6. Now we can add 2 plus 6 is 8. So our perimeter is 8. Again, we can simply count our spaces on our geoboard. 1, 2, 3, 4, 5, 6, 7, and 8. You can use your circular grid on your Geoboard as a clock to teach children how to tell time. Doing so, I will use a single solid black band to represent the minute hand. And I will also combine a black band and an orange band so that I still can stretch from peg to peg, but we know that the shorter hand is the hour hand. So we'll center this, the black end into the center, and then the orange end onto the outer edge, so that we know that here we have our hour hand and here we have our minute hand. What time are we showing? Showing 9 o'clock. We can change this in any direction. Now what time are we showing? Well, we know that each number around the clock is 5. So 5, 10, it is 6:10. We can also do another example. Now we have 4:45. We can also use this to teach students clockwise versus counterclockwise.